Hello everyone, and this is practicing percentage problems. So if you're watching this video, then you have already tried this worksheet and you've tried both pages because there are 2 pages. You've tried these word problems and you are trying to figure out, did I do that right? Well, I'm here to tell you one way or the other. So here's all the answers. No, that's not how this works. We're going to go through these one at a time, one by one. And as we've talked about before, we have a percent problem, so we're going to have a part, a whole, and a percent for all of these. And you know, Ms. J, I am going to be color coordinating all of it. So, solve the following percent problems, showing your work in the boxes below. What is 10% of 125? So if I'm trying to find 10% of a number, I'm trying to find that of the whole. So actually, I'm looking ahead. What is 25% of 48? What is 12% of 75? These 3 problems are all going to be solved the same way. Well, I might do it a little bit differently. Actually, you know what? No, I'm going to do it differently for all of them, but they're all going to be solved trying to find the part. So I need to know the part. Well, something out of 125 equals 10%. 10% is actually pretty easy, isn't it? This is one that we've practiced in school. I'm going to draw a diagram just so we have it. 0%, 100%, and our whole is 125. If I want 10%, 2, 3, 4, 1, 2, 3, 4, I want this bit right here. And so to find that, I need to do 125 divided by 10, which I know I move the place values over one place. The decimal shifts 1 point to the left, and that gives me 12 and 5/10. 12 and 5/10 over 125 gives me 10%. So that is my answer to this problem. The next one is 25% of 48. So my whole is 48, and I want to find 25%. I'm going to use equivalent fractions to solve this one because I know that 25% is equal to 1/4. And when I lay it out this way, 4 times 12 gives me 48. 1 times 12 gives me 12. So the answer to this problem is 12. 25% of 48 is 12. Now the next one is 12% of 75. That one's kind of gross. I'm going to solve this 2 ways. I'm going to try it using multiplication because I'm finding 12% of a number, and then I'm going to check it with some kind of equivalent fraction thing and see if I could have solved it that way. But 12% of 75. I can rewrite 12% as a decimal, 0 and 12/100ths. Of just means multiply, and 75. So let me do the math. 75 times 12 is 2 times 5 is 10. Regroup the 1. 2 times 7 is 14, plus 1 is 15, put a 0. 1 times 5 is 5, 1 times 7 is 7. Add them up, 0, 10, 9, and then 1, 2 places after the decimal point, so 1, 2. I get 9 out of 75. So me getting a whole number tells me there's probably a way I could have done this using equivalent fractions. Just don't know how yet. Let's take a look at 1200ths. I know I can divide both of those by 4. 12 divided by 4 equals 3, and 100 divided by 4 gives me 25. Oh, that's what it is. So when you get 3/25ths, you can simplify 12%, write it as a fraction. You get 12 over 100. That gives you 3/25ths. And then when you're going to 75, you can check that times 3, and that works out rather nicely. So 12% of 75 is 9. And that's all the work I did for that problem. Those 3 were all similar because I was missing the part each time. Let's see if that's true this time. Kai's video game is downloading, and it's currently at 60%, and 24 gigabytes have already downloaded. How large is the video game? So if 24 gigabytes have downloaded and it's not done downloading, 24 gigabytes has to be the part, which means that the full size of the video game is the whole, and this time I'm missing the whole. So the part is 24 gigabytes. I don't know what the whole is, and that's going to equal 60%. I want to draw this one out. I really like the tape diagram. So I'm going to do this, 0 to 100, and I want 60. 60 is a multiple of 10, so I'm going to break this up into tenths. 1, 2, 3, 4, 1, 2, 3, 4, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100%. So we've already downloaded 60%. Right there. And I know my part, which is 24 gigabytes. So if 60% is 24 gigabytes, then I need to figure out what I'm counting by here. To get down to 10%, which is one of my units, 60 divided by 6 gives me 10. 24 divided by 6 gives me 4 gigabytes. So 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. 4. There we go. Times 10 gives me 40. And 10 times 10 gives me my full 100% of my video game. So this video game is 40 gigabytes large. Now I've got my work. I'm going to have to write a sentence. How large is the video game? The, capital T, video game is 40 gigabytes. Period. I am so counting capital letters and periods on this test. We are in 6th grade. That should be common practice. All right. So that is my work for the first page. On to the second. Kai's brother is downloading the same video game, which means that one is also 40 gigabytes in total. I know that from the problem I just solved. but it's only 20% done. How many gigabytes have been downloaded so far? So this is the opposite of the last one. This time I don't know the part, but I do know the whole is 40 gigabytes. And I know that we're 20% done. So let's draw it out. 0%, 100%. This is 20, so I can count by fives. 5 sections. 20%, 40%, 60%, 80%. So his computer is going a little bit slow there, but that's all right. Or maybe he started downloading it late. 20% is something. I don't know what that something is, but I do remember from last time that the whole thing is 40 gigabytes. So what's 40 divided by 5 sections? 8. 8 gigabytes. So now I know that he has only downloaded 8 gigabytes so far. How many gigabytes has been downloaded so far? Kai's brother, capital K, also because it's a name. Kai's brother's video game has downloaded 8 gigabytes so far, period. So that is that problem. And if you did do an equivalent fraction way and you want to just check your work, 20% is 20 out of 100, which can be simplified to 2/10. And then we can bring that up to 40 gigabytes by going times 4 times 4 and getting 8 over 40. Kai's father has been baking cookies while the boys download their video games. They've been timing him, and the cookies have been in the oven for 4 minutes. When asked, Dad says they're only 25% done. How much longer do the boys need to wait for their cookies to finish? Well, let's see. They're 25% done. I know cookies don't take 4 minutes, and they've been in there for 4 minutes, but they're not finished, so that has to be the part. Question is, how much longer do they have to wait? Well, if I want to, I know 25% is 1/4, so I'm going to use equivalent fractions on this one. 1 times 4 gives me 4. 4 times 4 gives me 16. Ooh, how much longer do the boys need to wait for their cookies to finish? It takes 16 minutes for the cookies to cook, but they've already been going for 4 minutes. So if I think about this on a tape diagram, 0 and 100%, you probably split it into fourths, 25, 50, 75, and 100. 0, 4, 8, 12, 16, and you said, 4 minutes is 25%. But the question was, how much longer do they have to go? Well, they have that much longer to go, which is 16 minus 4, which is 12 minutes left. The boys need to wait 12 period. And not 12 minutes. Units are important. So there we have it. Those are our percent problems. Notice I set up part, whole, and percent for each and every one of them. No matter what the problem was, I've got my part whole in percent written out. That is an important way to organize your work, and I expect to see that on the test. But that's it for now. So, bye.